So I wanted to thank everybody for coming to my Getting Started with Microbit. And also we're going to dive into another cool feature that the Microbit Foundation has recently released called the Microbit Classroom. So I hopefully we'll get some time to explore that as we go through. So a little bit about myself. I guess I should start off with that. I'm a technology educator here at the University of Ottawa Engineering Outreach Team. We love to include classroom workshops, teacher training, all those sorts of fun stuff. And right now I'm sort of on this kick about Microbit and sharing it with as many people as I can. So in terms of what I'd like to do for today's workshop is look at a few links to curriculum in Nova Scotia and how you might be able to use the Microbit in there. And I guess specifically in terms of math, but we know with coding, and some of you have probably done some coding workshops over the last few days of this wonderful conference, is coding can really be incorporated in any type of lessons, and so we're gonna see how we can do that in math in particular. We're gonna look at the MakeCode platform and how we can look at this in terms of synchronous or asynchronous opportunities with your students. You know, as we go forward into September and the fall, and you know, things were rolled out, but you know how or the unfortunate reality that we are going forward with, that it is a little bit fluid. And then I have a few takeaway projects for you that I've already pre-created that you can go ahead and tinker with, and then also we'll create some throughout our time today together. So as we look at the strands in the mathematics curriculum, there's 5 main strands that I took out of those. So numbers, patterns and relation, measurements, geometry, statistics, and probability. And so we can see how a lot of our opportunities, we're going to come and we're going to touch on those throughout our next time together. If we also look at the mathematical process in the Nova Scotia curriculum, we can see there are those 6 different, 7 different outcomes that are related, that are across all grade levels. So communication, problem solving, connections, mental math and estimation, technology, visualization, and reasoning. And if we look at math and we also look at coding, we can see how a lot of these are linked right away. So problem solving, there's a lot of problem solving within math, and there's a lot of problem solving within coding. Communication, if you're not understanding how your code is working or how it works or why it works, or you want to share it with other people, well, we need to think about that. So I won't dwell too much on this, but I just wanted to remind ourselves about the links that we can see within the math curriculum in Nova Scotia. So first of all, some of you might be wondering, what is a microbit? Well, a microbit is a small portable device that's about the size of half a credit card. I knew I forgot to grab something. So I just have one right here. And the cool thing about it is it has some LEDs right on there. Hopefully everybody can see that nicely. So we've got LEDs on there. It's got a couple buttons for us to be able to interact with. It's got a compass, so it has the ability to measure magnetic field. It has an accelerometer, so you can see it has a sense of the orientation, if it's been shaken or not, and it has that ability for radio and Bluetooth antenna, so it can connect microbit to microbit, microbit to tablet, microbit to phone, microbit to computer. And then there's a whole bunch of these connectors down at the bottom which you'll see there, edge connectors, we call them. And so those edge connectors allow us to connect to a lot of other things. So just the hardware itself is really powerful to use, but then there's a lot of possibilities with that. Now we're going to be using the simulator today, the digital simulator, and there's still lots of things that we can do with it. But if you have a class set, and I'll share some ideas at the end, then there's opportunities for you to go beyond just some of these basic things that we're going to be doing. Well, I don't say basic things. Some of the simulator-only things that we'll talk about today. So let's first talk a little bit about the code itself, and how we can use this to do some coding. So we're talking about, you know, what to do or what can we do with our certain blocks. So we have the ability to remember a certain value or update that certain value. So thinking about counting, we can do those sort of things. We're able to display a certain value. So display a certain number that we're counting with. We can display some text. We can also do some plotting. So use that 25 LEDs as a way of turning on and off to do things. So it's almost like a little graph that we can use if we wanted to. And then more specifically, thinking about mathematical functions that we can do. So we can do basic arithmetic expressions, so adding, subtracting, division, exponentials. We can do some basic integer functions, so rounding, truncating, absolute, mix, minimum, maximum, randomization. So there's different opportunities there. And then we can get into more complex things with math. So looking at real numbers, trigonometry, square roots. So there's a lot of opportunities in that math section, which we'll dive into just a little bit later. And then there's the when to do it. So are we thinking about at the beginning? So we can do an on start. Is it when we're looking at the button? So looking for an input to start a certain action. So we can use those buttons, or we can use the physical shaking of the microbit, or if the Lego logo is up, logo is down. So we can do those types of things as well with it. So yeah, so what we're going to do, and we're going to jump over to make code in a few seconds here, is we'll create a few simple math programs, and I'll show some examples of using the onboard sensors as part of some math examples as well. So one thing is, if I'm going too quickly, or you miss something, these slides will be accessible in the folder for later viewing. So if I'm too quick, or you want to review it later, then you can see that. But if you wanted to follow along, you're more than welcome to do so now. So most of you are probably on a device, or one would hope that you're on a device. So you've got Meet and a web browser tab that you'll open up. And if you wanted to sort of orientate them like this, so that you can see myself with the code that I'm doing, and you'll see your web browser as well, so that you can sort of follow along with what I'm doing. All right. So the first example, so like I said, I'm just going to jump out of here, and I'm going to go to makecode.microbit.org. And so I'm going to put that link in the chat. You just want to click that. So it just takes a few seconds to load up. And you'll probably see something like similar to this, and depending on if you've interacted with the screen or with microbit before, you will have some projects here. If not, you'll have it all blank. So I'm going to go ahead and I'm going to create a new project. Actually, just before that, I'm going to show that there are lots of tutorials down here, lots of great examples of things that you can do in class. And I know that some of you have done some really interesting things as well. So I'm going to click on New Project. I'm going to give my project a name. So we're going to call this Simple Counting. And if at any point you want me to slow down, please let me know in the chat. But I assume that everybody is following at pace or ahead. So while we see this coming up here, we're going to, yeah, so there it is. So we see the simulator on the left-hand side. We see our scripts that we'll be using, or our code blocks that we'll be using in the middle here. And on the right-hand side, we see where we can drop our code in and explore with that. And then down at the bottom here is the ability to download it onto the microbit if we had any. But again, since we don't have the microbit, we're just going to use the onboard simulator or the online simulator for now. All right, I'll give everybody a minute. All right, so what we're going to be doing on this one, so as I said, like a simple counting. So if we think back to how we can keep track of things, that is, we're going to be using what are called variables. And so variables are that way of keeping track of something. It's I always equate it to like a container that we can put different things in. So like a lunch box, you have a lunch box every day. You're going to have your lunch, and so you've got your Batman lunchbox, or your Superman, or your My Little Pony. And in that lunchbox, the contents can change every day. And so you could be, it's Taco Tuesday or it's Fish Friday. So the things inside will change. And so we're going to create a variable that we can display that number. And so here we can just have, so now we've got our ability that we can see what the count is. We can set count, and we can change count. And so we're going to use all of these three blocks at some point during this program. So we're going to start off and we're going to set count to 0, because often when we start counting, we always count from 0. And then what we're going to be doing is we're going to use our buttons to help us count. And so we need to go over, this is a source of input. So we're going to go to our input blocks, and we'll see on button A pressed the ability to perform an action. And so again, we just sort of drag that out, and we can start adding this in here. So we're going to go back to our variables, and we're going to change count. And we can leave this as change count by 1. And then because we so I can right now run my program. So it's running. I can press the stop to stop it running, press the start, and so it's running. Now we can't see anything running because I have yet to display anything. But if I clicked on my button, I would assume that my count value has now increased. But again, we don't see this. We want to have some sort of feedback, a way of knowing if what we've done is correct or if we need to change our code. So we can utilize this forever and the ability to display a number. And so similar to what we have done before, we grab our number and we we can put this inside. So a few different things that I'll mention right now is the ability, you'll sort of see that there's a shadow that arises when I get a block close to another block. So that shows me that's where it's going to go. The other thing also is you'll see that there is this yellow part that will appear, and it will show you where it's going to be connecting. And so we're just going to put that back. But again, just to show you where things and how things are going together. And this is all sort of come out of the idea of building blocks with coding. And so now we need to show a number, but again, if I click on this, I'm still showing 0. So we need to sort of update this value for count. So I'm going to go back to variables, and I'm going to grab on this one. So you'll see that there's this little sort of, I heard a friend of mine called it a pimple. So this little pimple that pops out of the variable, and it allows us to know where it's going to go in. So if we have multiple of these blocks that are round, you'll see that it will go into this particular one. So if I just let it refresh, you see a refresh. Now when I press on A, it will update, and there we go. So now we have a very simple counting program that will count the number as we increase. All right. Now with code, there's a few different ways to run this, but this is one opportunity. So as we see, we can keep counting. So I will leave this on here for about 30 seconds. If anybody has any questions or comments, then we can open the floor. If not, I will move on to my next little demo. Great, I think we're good on that one. So because I like to keep track of my my code and see the progression, the things that I've learned, I'm not gonna modify this one because I've called it simple counting. I'm just gonna go back home. So again, on the top left-hand corner, you're gonna click home. And then what we can do, a nice little hack that you might be interested in, is I already liked what I had done in my simple counting, and I'm just gonna change a few things with it. So I'm going to click this view all. So that's going to show me all of my projects that I have. And this simple counting, I like it. And so what I'm going to do is I'm actually going to duplicate it. So instead of opening it, I'm going to duplicate. And so now I'm going to call this complex counting. Duplicate. So now I have another program called complex counting. So if I just click on it and now click open, we'll see it pop up. So it has the same exact code on the inside, but now it's called complex counting. So my simple counting is untouched. I've made a duplicate of it, and now I can get into some more complex coding and complex counting with this one and have two of those programs. So now that I've got my count, again, I'm starting at 0. Here, I could do something maybe more skip counting related. So instead of counting by 1, I can count by 3 with button A. And then maybe if I want to duplicate this and have button B, so now that we've got button A and button B, again, we can use those here. So you'll see that this is all great and hashed out. So that means that we can't have two processes competing with each other. So what we want to do is click on there, that little drop down, and we have now access to B. And so I can pick, this is 7, for example. So now if I press play, so again, we've got our count started off at 0. Zoom in. I just realized that people might not be able to see great. Here. So if I press A, it increases by 3. So 3, 6, 9. And then if I wanted to add 7, so 9 plus 7 is 16. So this is an opportunity for us to explore skip counting. So and we can, we can use this in classrooms with different reasons. So we're looking at skip counting to a certain value, or what are our options for getting to a certain value. So if we wanted to get to 25 with the combination of 3 and 7, can we ever get to 25? So that ability is to to explore through that. So I got to 23, and then if I add A again, I'm going to be at 26. So I've gone over. So I can reset, and then I can start again. So I can start maybe with like 2 of these. So I'm at 14. And then will I ever get to 25? Yes or no? So that's an opportunity that you can explore with your students. So those are some ideas. Again, I've got those in the slide deck, so you don't have to worry about frantically taking notes. But you're more than welcome to frantically take notes if you'd like. So that was my next example of skip counting or counting. So the next thing I wanted to do is actually I'm going to go home, and I'm going to again copy this one out. So I'll click on View All. I'm going to click on the little box here, or that's not a box, that's a circle. Complex coding, and I'm going to duplicate it, and now I'm going to call it adding and doubling. So now that I've got this adding and doubling, I can click on it, click open, and now it will open with that. So you'll see that now I've got simple counting, complex counting, and adding and doubling. So now I've kept a record of all of the projects that I have, which is great to go back and I can review my learning. If your students are interested in, oh, what did I do in that project that I did yesterday? Well, I can go back and look at it later. So this one is going to be adding and doubling. So if we just, again, think about what that means. So we can have A is adding a certain value. So we can add 3 or 2 to a certain value. And then we can have that B could be doubling. And so what does it mean to double something? So there's 2 different ways to do that. Does anybody want to share one possible way of doubling a value? Well, I take a sip of my water. Anybody? So we have a value, and we could add it to itself. Yes, excellent. Oh, you just cut and paste it from each other. Awesome, great job. So yeah, you can add it to itself or multiply by 2. Exactly. So those are 2 options that we can use. So I'm going to add it to itself, but if you wanted to multiply by 2, you can do that, and you can sort of give those little challenges to students and see how they think about how they would build it out. And in math, just like in coding, there are multiple pathways to get to the same answer. So we're going to change the count, and we're going to change it by adding itself. And so we're going to just grab in our count, and so we're going to change count by count. So if this value, for example, we press play, so I press it twice, A has been pressed twice, so now I have 4. And so if I take the value, so count is now equal to 4. If I add or change count by count, so change count by 4, which is the current value, it will be 8. There we go. So we can see how we can add 2 and then double it. sort of thing. So another opportunity to explore with growth as we and patterning, so we can look at different patterns as we go through here. All right, so if there's no other questions. So again, I'm just going to jump back over to my PowerPoint and quickly go through just a review of some of the things that we've done already together. So we've done a basic counting, and on the left-hand side, you'll see sort of the pseudocode or in plain English, what is happening. And then on the right-hand side, you'll see the code or an example of code. So you'll see that my example here is a little bit different than what I had for my basic counting. And then we've got a few examples of what we could do. So we can keep score, so 2 microbits. We can keep score of things that we're doing, or rock, paper, scissors. We're keeping score that way. We're counting off steps. We can look at certain addition problems. So, one person's got a microbit and they pick a number, and then someone else has got a microbit, they got a number, and then we can add those two together. And so we can see how getting started with some basic coding, we can get the kids in there. Then we've got our skip counting. So again, same sort of idea. We've got updating by 2 on this case, and updating by 5 on this one. So again, you can see how I've broken it down on button A and button B, and then we can look at some simple tasks that we can do. Skip counting. How many different ways can we get to a certain value? Can we get to a certain value with just 2s? So those type of things that we can think about. And then the example of adding and doubling. So again, we can add itself or multiply by 2. Thanks for both those suggestions. And then we can think about, again, can we get to a certain value, or we're just practicing our doubling mathematics as we go along. All right, so the next thing I wanted to show, and these are good examples maybe for asynchronous opportunities, when you're, you demonstrate something and then the students are working away. But next I wanted to demonstrate something that's more an option for asynchronous. And that means both for an in-person and a virtual opportunity. And so we're going to actually use it through asynchronous or through synchronous virtual opportunity. There's now so many possibilities with learning, it's overwhelming. Anyway, so what I want to do is I'm going to jump a few slides ahead. Again, I've got the code here for you. So those are just clickable links. It'll go straight into the simulator, and then you can explore those on your own. And then there's a couple other ones that I'll share a little bit about, and there's one that I'll bring into the classroom that we can explore. And then I've got a bonus patterning activity that's like all set up, ready to go as a Google Doc that you can share with your students as you wish. So the next thing that I wanted to talk about is microbit classroom. So not to be confused with Google Classroom, which I might mention because you know how it is when you got Google on the brain. But so how can we use these particular math activities with your students in a remote setting or in a in-person setting? So this, like I said, is great for you to be able to support your students in both virtual and in-person opportunities. So it's a very easy way to look and sort of manage and review your students' code. The one nice thing that's really great is the ability to use it without any logins. It's no registration, sort of no hassle setup. I'm gonna sort of live set it up. So So you can see how relatively easy it is, and you will join, or I invite you to join as a student, so you get the student's perspective from it. Now, I've also gone through the step-by-step of it through here, so you can, if you miss something, there's the recording, but as well, I've done a step-by-step with some screen grabs for you. So, as I mentioned, it's a great way to manage, and again, remote classroom, or you can use this while you're in person. It's great for you as the teacher to be able to sort of push out code to them already, and to have the students also send their code back to you. And it allows you to sort of quote unquote look over the student's shoulders. So often we circulate. That's what we do as teachers. We circulate around the classroom. How are you doing? Do you need some help? Oh, I love that project. Those sort of things. So it's very hard for us to do that remotely, but we can do that here in this ability. And yes, and as you say, you can push out certain code to certain students, so you can have that differentiation right away from the beginning. So. Let's get to it. So I won't show it from the through here. I'm going to just show it live in person. So you don't need to go to any website yet. I will share in a moment a website to go to, and then we will. Yeah. So this one is going to be. Let's just call it math LEDs or something. I don't know. So you have the ability to choose a programming language. So we're going to use Make Code to get started. And then you have the ability to use your local storage or not. So it's really up to you if you want to do that. I'm going to leave it check marked. But again, it's what that means is like the stuff, is it saved within the cache of the browser or not? At the end, you can download everything to your computer, and then you can store it and then restart those activities if you want. So if you're doing something over multiple days with students, I would suggest this as an opportunity. So one way you can either start with your own activities. So let's say that you've started some code and you're going to push it out to students. Or you can do some of the lessons that are available on their website, on the microbit website. And I have a slide at the end to show some of those things. Hopefully we'll get there. So we're going to launch the classroom. So it's going to start. And it's pretty well 4 easy main steps. And as you can see, they're right there. So we need to complete the code setup. So right now, there's no code pushed out to the students, so we need to do that. And so we can either click up here on the top for the editor, or we can show me the editor page. So I'm just going to click up here, and it's these 4 main steps right here. So we're going to click editor. We've now got our blocks ready to go if we want. So if I wanted to give you some code, I can push that here. And if we wanted to, so I can automatically start off with a loop if I wanted to. So this is me just throwing some things together. Or if I wanted to, I could also import my code to you. So I think, yeah, that's what I'm going to do. So I'm just going to bring that on here, and I can just drag it and drop it. So I have a hex file that I've already downloaded on my computer, and I can just drop it into here, and you'll see the code pop up as we speak. This takes a little bit of time. Hopefully it comes along. There we go. Okay, so this was the template that I had created for my students. Who are you? So this looks great. I enjoy the layout, and I know everything's there. And I'm going to share this code with students. So I click on this button, and it pushes it out to the students. Now, You're going to say, well, there's no students yet. Well, it gets it ready so when the students join, they will automatically start off with that ability. So the next is going to the dashboard. So the dashboard is where you, as the student, can join. And so you're going to go ahead to that join link, and then you're going to go in and you'll see that there are drop downs, and you're going to pick pink rabbit car umbrella as the options, and then you're going to put into this pin. And so this pin and the classroom name are unique to this instant right now. And so this is where I mentioned it needs to be a synchronous session, but in person or online. Whereas what we had done before is more of an asynchronous / synchronous opportunity. I find this is an awesome opportunity when you have a synchronous experience with students. And the ideal situation is you will have the students join in, and you can see, thanks Suzanne for joining in. Susan. You'll have the students join in, and you can see them there, and then we'll see their progress in a bit. All right, so we've got Nick and great. So again, the chat is still there, so I put those things in the chat if you wanted to join when you wanted to, if you feel comfortable to. So now that I've done this, I can go into the student code. So again, now I can click on the student code, and I can actually see what the students are working on. And so on the right-hand side, I can see my students, so Anne, Nick, and Susan. And then as this is loading, I can see their progress. And what happens is, as they sort of drag and drop, it sort of refreshes their code and allows me to see in real time what they're doing. And so if I go and see what Anne is working on, it will come up with something. Oh, and Jarman's there. Great. So again, people can join in when they want to. It's taking a little while to load, but that is what technology is, right? So while we're waiting for that to load, you can see that we can see everybody is in progress. And when someone feels comfortable with their code, they can click in the top right-hand corner the ability to submit their code. And then I can see that in real time. Again, then I can go in and look at their code and say, yep, that looks good, or no, you can do some work. So I can have the ability to then change their progress back to in progress as opposed to completed. And so this is an opportunity. And when you click submit, it shows you 5 emojis. Thanks very much, Nick, for doing that. So I'm just going to jump into yours. Clearly, the code part doesn't want to load for me. But if I click on oh, there it is. So I see that Nick started off well. He's got his set numbers, great. His changing numbers, that's good. But he's needs a little bit of support on the loops. Hint, hint, there's nested loops in there. So you want to be plotting in the middle, and then you have index, like a 4 index and then a 4 index. So like, so it's growing out. So I'll give you that little hint. So what I can do is click on this little button right here, the sort of pen to mark it, and I can say in progress. So now I've given Nick some feedback, apply those changes, and then if Nick hasn't closed his browser, or if he has closed his browser, if he hasn't closed it, it will show him active again, and so he can get back in there and change his code. If he has closed his browser again, he can just go back to the same microbit.org/join, pink rabbit car umbrella with the unique pin, and then he can just pick his name from a drop-down menu. And and so he's allowed to sort of join back in as Nick, and then he can add some more into his code to make sure it's a complete code. And then you can use that to, you know, again, you can have different starter projects that you share with certain kids, or you can have the ability to, you know, let's say, how are people doing? Or you're just exploring. That's great. So what I could do too is if someone is more advanced than others, so Susan is working away, looks great. What I'm going to do is I'm going to take your code and I can share it with the other students. So I see that Susan's progressing well, but Jarman and Anne are struggling, or Jarman is struggling. So then I can push out that code to them. So I just click on Anne, and then I click on Jarman, and then I can send that code. And so it'll push out your code. And if you went off on your own tangent, or you're not sure where to start, that's okay. I have the finished, completed code for you. So you don't, this is just me giving you an example of it. So, and I know this is a more complex thing in there, but I just wanted to show you this for demonstration purposes. But yeah, so great. So you can see how you can get your code and push it to other students. So the other thing is, if you're, you know, students are having some struggles, you would probably be doing this in a meet type of scenario as well. And so you can, or you can have a office hours, and the students would sort of be working on this synchronously, but not through the web. And so they can ask for help. So the way to really ask for help is if you right click and then do add comment, that's way that you can do it. There's no way for you to have like a chat option in there, if that's what you're thinking, Anne. But I think that's a good option, though. I think that would be a really good feedback. I'm going to make a note of that. I'll share it with my friends at Microbit. But usually you're doing this as a supplementary, like during a Google Meet or a Zoom or Teams or however you're virtually connecting with them. And so you're just there to support, and you can have like a little breakout room that, you know, if Nick needs help, I can say, hey, Nick, meet me in the breakout room, and then you can support him one-on-one. So to finish this off, you can save the classroom. And so I'm just going to go over to save the classroom file. So it's, again, 3-step process, or 2-step, really. So I'm going to end the classroom by first downloading the classroom HTML file. And so that HTML file takes all of the students, all of their code, and puts it into one single HTML file. And then I can click on end session. So sorry if any of you are still in there. I'm just going to end the session because I want to demonstrate ending it. And so it will remind me, do I want to end it without downloading it or download it? So I've already downloaded it. So I'm just going to end without downloading it. And now I'm finished. Now, if I want to resume what we were doing, let's say it's, 24 hours pass and we're coming back together. Let's pick up where we left off. So what I can do is I can go into my downloads folder and navigate to this HTML file. I sort of don't want you to see my downloads folder, but it's there. And if I double click on it, it shows me this. So I just double clicked on it on my other screen, and you'll see what we've got here. So resume classroom. So I'm going to bring it back. So activity name, the date that it was saved. So it was saved today. Number of students. Yep, this is the correct activity. Resume classroom session. So now what happens is it makes another unique classroom code or classroom code in terms of it's not going to be pink rabbit anymore. So I'm going to go back to the dashboard. And now it's a blue frog on the bus playing a guitar. So we have a new classroom name, a new unique pin, and then students can join back in. And so you can see I have my students already here. So from the drop down, you can pick you, or if we had Jimmy and Sally were also joining the class because they missed it out, they can then join as well. And so you have that ability is there. And then you can pick up where you left off with that. So are there any questions about the microbit classroom? Or is it like, oh my gosh, I never knew about this and love to learn more? Or everybody is left, their head exploded. Yeah, awesome. Well, Anne, I'd love to teach you more if you want. We can chat more about this for sure. And I'll give you my contact information at the end. So, all right, so let's go. I'm just going to jump ahead. So again, I don't need to show you all these things because it's already step by step what it did. So what I wanted to demonstrate, at least for the next little bit, is some ways of using the onboard sensors. So again, if you don't have microbits, this might be difficult, but there are opportunities out there to get microbits. So I'll have a few examples later on. So we can use some of the onboard sensors to create relatively simple activities that you can use when you return into the classroom. And if I'm ever in Halifax and you let me know, so my parents are in Halifax, so I make the trip often. So if you let me know in advance, I can bring some of these ideas down with me, and so you can see them. So the first example is creating a trundle wheel. So some of you might know this from phys ed, counting off steps or using that. So I've got, I guess you could say like I think is my webcam still running? People can still see it. So these were sponsored by 1 for 1 Pizza, just because that is the garbage I go through. Yeah, so these are laser cuts. Again, if you don't have a laser cutter, then you can just use scissors. That's, again, reminding the students to be safe to do that. But to draw a circle, if you don't have a laser cutter, is you can just take a string with a little push pin in the middle, and then put a pen on the outside, and then it will have the same radius all the way around. So that's a little hack to create a relatively good circle. But these are good, and I designed them such that they're a meter around. So the circumference is exactly a meter. So you can then take this, and then another little handle, which I laser cut, but again, you can just use scissors, and one of these little brass fasteners, and then you've got a trundle wheel that you can use in your classroom. So roll it around. That's great. Now you can hack it with a microbit to help us to be able to measure things with it. So here is the example of the code. So we're going to start off our counting at -1 because we want it to start as soon as it reaches the 0 mark. We're going to start counting from 0. So it sort of allows us that little leeway at the beginning. And then I can just explain our code here. So when the logo is up, so again, on the microbit, there's a little logo. So if you tape it so that the brass part is facing the brass fastener, as it goes around, the logo will be down and then back up again. And so it will change the counting by 1. Oh, we've done counting before. And then if you wanted to restart counting, we have the ability to press A and B together to do that. And then we can start counting. So this little part right here is to show how many meters we've gone. And if we wanted to press A, we can multiply by 100 to show us how many centimeters we've gone. And so if you wanted to break this down, when logo up, counting, logo up, we can have counting by 1. But if you want to have like logo down is by 0.5, logo up is 0.5. So that ability to measure not just meter increments, but half meter increments. So you can get more, fancy with this if you want to. But again, a relatively simple example of how you can do some cardboard making with that. The last one that I wanted to share with you is a clinometer. So here again, I've got a clinometer. It has the ability, a little crosshair there, so I can use the fact that there is an onboard tilt sensor to look at how tall something is. So the combination of these two, so how far it is away and how tall is it, or what's the angle, we can do some math in there, which again might be a little bit beyond your students, but depending on what grade level, or you can find out how tall that tree is. There's a link to me explaining mine on Twitter if you wanted to watch that. I won't go through that just because we are running low on time, and I wanted to allow questions. So there's the code there. We'll skip that. So lots of resources to get started. So I've got a Wakelet of some getting started resources. I'm always adding things into it. So if you want to follow that, there are the resources on the microbit website. So there's different projects, different lessons, the Make Code project coding page. They also have, just because of you're probably thinking about, like, if I go back, what am I going to do in terms of safety with these? So they just released a news article about, or not just, a few days ago, 6 days ago, about planning safely with students in mind. So I would encourage you to have a look at that. There's the microbit classroom link. There's also more resources in terms of coding with them, in terms of thinking about project building. So the Micromag website magazine is really good. There's more code.org you might have heard of, has got some great resources available there. A nice book, which I sort of like. I think this book is also in my Wakelet, where you can purchase them. And then also some great resources from the Raspberry Pi Foundation through Code Club, a lot of getting started. And in fact, they've got lots of stuff to do with Scratch and Raspberry Pi and all sorts of cool things. And yeah, so I'll stop there. I want to thank you for your time, for attending. I would love some feedback. Please reach out if there's anything. I'd love to support you and your students in the classrooms, both in English and in French. I could have mentioned that, I guess, but yeah.